Now again, notice that we obtained this function, and I'm afraid I might have had the camera focused poorly on the last one. We obtained this function by taking this expression for v0x and this expression, all this over this, for the delta t. We put them together and we get a function h, a function x that's a function of just h, if we know L. And presumably we're going to measure the ramp, so we'll know L. That's fine. As we said, we don't know what this graph is going to look like. I know because I've graphed it. Let's see if we can simplify this mess a little bit and just see what kind of functions we have. I know that a minute ago you were looking at this whole page and hoping it would just go away, but it's not going to, so let's take a look at it. Now, the algebra steps here are simple enough, but that doesn't mean that it's simple to think of them and to see exactly where to go. So let's just look at some of the algebra that goes on here. In the first place, this L here in the denominator is really a factor of the entire numerator, because everything here is multiplied together and then all this is multiplied by all of this. So we could actually factor out a 1 over L here, and then when we do, we'd have 1 over L times this entire fraction without the L here, and we'd get an L squared in the denominator. So that's the first thing we do to simplify this. We have a complex fraction. We have a fraction in the numerator. We don't want that. So we bring the L squared, or we factor out the 1 over L and get an L squared in the denominator. What do we do next? Well, we can combine these two terms. This is a square root times a square root, so we just take the square root of the product. 1960h times L squared minus h squared, all the stuff we had here comes under the same square root, and we'll eventually be able to multiply that if we want to. H times L squared minus h squared. What's that going to give us? Well, that would give us a polynomial in h. Again, L is just a number, so we'd have L squared h minus h cubed, a cubic polynomial under this square root. So our old friend the polynomial rears its ugly head, although polynomials aren't all that ugly. Then we're going to take this square root and we're going to distribute it through this addition. The addition of the negative square root of 1960h cubed and the square root of this stuff. And when we do that, we get this times this, which will be a negative all this. We bring everything under the same square root, plus this times this, which is going to be here. Now, you probably can't even read all the numbers there, but you can read all the numbers here and here and here. When you get down to here, it should be obvious what you're going to get. Just in case it isn't, let's zoom in on it a little bit. And we see that this stuff over here that's especially hard to read is just, again, what we get when we multiply the square root of 1960h times L squared minus h squared that's out in front by this thing. Okay? So, what do we have at this point? Now, let's come back up here and see if we can comprehend what we've got. Well, actually, I've done a step here, so let me come back and show you this. Now, what are we going to do with this? Let's put this back down here for a minute. Under this first radical, we've got a bunch of stuff that we can multiply. H cubed times h is h to the fourth, and then we can multiply that through the L squared minus h squared. We've got a 1960 and a 1960, which is a 1960 squared. Being under the square root, we're going to eventually be able to factor that out. Over here, well, we have some more stuff to multiply out. So just using the distributive law and keeping our wits about us, we go ahead and multiply this whole mess out. And I'm not going to go through the details one by one, but this is the expression that we get. Okay, let's go ahead and zoom in. a little bit. Now the first expression, the square root of 1960 squared, it's negative, times L squared h to the fourth minus h to the sixth. The second term is square root of 1960 squared times a polynomial negative h to the sixth plus L squared h to the fourth minus 190,000 over 1960, L squared h cubed minus L to the fourth h. Okay, to bring that 1960 out here, I had to divide it over here. If I multiply this back out, I'll get back to where I was. Then we simplify this term. Now we're going to factor out the 1960 squared from both of these things, and we'll see how that works. But that's just going to leave us all of this stuff here. And 190,000 over 1960 is about 96. So we'll have 96 in front of this, and 96 in front of this, and we get this. Over here, we get this after we factor out the 1960 squared. Now, factoring out 1960 squared gives us a 1960, which we divide by the 980 and get 2. We keep the L squared in the denominator, so we have 2 over L squared times this stuff, and now the polynomial is starting to get a little bit more manageable. And in a minute we'll see how we do a final simplification of the polynomial and even figure out a little bit about what its graph might look like.